Well, welcome. Here we go on topic 1.3, where we're going to be looking at a lot of graphs. It will be estimating the limit values from graphs. So lots of details in this one, a little bit more in-depth notes today. So let's just get started. So limit notation, one-sided notations as well. If we want to find the limit of f of x as x approaches some value, let's say c, from the left-hand side, we would write the limit as x approaches c from the left. So c with the minus sign up, like a superscript position. And then since they mentioned the function f of x, I would say f of x. And then that would equal some number if it existed. The second sentence says if we want to find a limit as we approach it from the right side, then I write the limit as x of x approaches c from the plus side. So a little larger than c from the right side of f of x equals. In order for a limit to exist at c, both cases must be true and be the same value. So the limit from the left side, as well as the limit from the right side of c, must be the same value. And then if it is, we can say the limit at c exists, and in this case, we just assigned it some variable L. Okay, in the blueprint, it says in order for a limit to exist, the function must be approaching the same y value as x approaches some value c from either the left or the right side. If this does not happen, then we say that the limit does not exist and does not exist as x approaches c. D and E will work as an abbreviation. Even on the AP exam, you may use D and E. Everybody understands that's a pretty common abbreviation. So just to give you a little bit of help on what we are talking about, let's say this is our function. And I'm going to spot C as being right here. Now, for the limit to exist, or for the limit as x approaches c from the left, that's an approach sign, of f of x, then I would be coming in from, remember how we talked about using arrows? I would be coming in to c from the left side, and it appears that it would be this value, whatever that was. Let's say it's -1 here, -2 here. So I could say that that limit is -2. If I switch gears and say I'm coming into C from the right-hand side, then I'm approaching C from this side, from the right side of C coming in, and that would have the same height, which would be -2. The answer to a limit is always a y value, okay? So we have many examples, 7 of them to be precise, and they are all, there's quite a bit to fill in here. So let's just walk through, and then I think I'll have you do a few on your own, and then you can check back in what my answers happen to be. All right, so for example 1, reading the notation, the limit as x approaches 1 from the left side, because it's got the minus, of f of x. So I'm going to locate 1, because my c value is 1. I'm coming in from the left side of that. That looks like it's coming into then a height, trying to draw a horizontal line there, of 1. The limit from the right side of c, or from 1, of f of x. So let me just switch my color here. Now I want to come in from the right of 1. So the right of 1 would be over on this side, wouldn't it? So I'm coming in and coming into there. The answer to this is 2. From the right side of x equals 1, I'm at a height of 2. The limit as we approach 1, well, my fingers, if I were to follow them, and I don't think I can do that, notice that there's a gap between here, right? I'm missing, they are not coming together at all. This is a D and E. The left side does not equal the right side, which has to be the case. These must equal. From the left of C and the right of C must equal in order to say that the limit exists. And in this particular case, we do not have the left and the right side agreeing. Finally, the last question is more of an algebraic question. What is f of 1? What is the function's value when x is 1? I'm looking at the dot then, and that says that it is 2. If you would, on this example number 2, make that an open circle. I can't remember if it was very clear or why I put that in there, but maybe they both look solid. And we don't want to have 2 points defined. If I did fill that in, I no longer have a function. So we need to make it a function so that we pass the vertical line test. All right, the limit as x approaches 1 from the left. From the left side, height comes in as a height of -1. As we approach 1 from the right side, coming in from the right-hand side of x equals 1, looks like my height is 1. Let me ask you, does the left side and the right side come together at the same height? Not in this case, right? So we once again have a D and E does not exist for the actual limit at C, at 1. What is f of 1? Please fill it in. I hope you chose 0 because that is where I see my dot. That's where the function's actually located. And this would have been an ordered pair of 1, 0. So the y value is 0. Example 3. See if you can do this one on your own. Hit pause, go fill it in, and then check your answers. So I'm looking from the left side of 1. I have a value of 1. From the right side of 1, I have a value of 1. The left and the right equal each other, so the limit does exist. It is 1. And f of 1, since this is an open circle, it does not, does not exist is typically used for limits. Undefined is really the term that we give to a function not having a value. It's not defined there at 1. All right, try example 4. Hit pause and go give it a shot. From the left of 1, I get 1. From the right of 1, I also get 1. I'm looking at the y values. The limit as we approach 1, since the left and the right do agree, I get 1. Now, what is f of 1? F of 1 is where the location is defined. And the function, when I put in 1, I get out -2. It's where the black dot is. Examples 5 and 6. 0 from the left is 1. 0 from the right is also 1. As we approach 0, since the left and the right agree, we have agreement that the limit as we approach 0 is 1. F of 0 is also 1. Now I know there's not an obvious dot, but the line is shaded when I have 0, 0, 1 is my location. All right. Example 6 looks a little interesting, doesn't it? As we approach 2 from the left side, so get your marker out. We're approaching 2 from the left side. Here is x being 2. It looks like it's a vertical asymptote. And it's headed downwards. It's headed to -infinity. From the right side of 2, okay, follow. I'm coming into 2 from the right-hand side. It's going sky high. It's going to +infinity. Do these agree? No, they're not headed up to infinity, and they're both not headed down to infinity. They're doing one or the other, right? There is no limit there. It does not exist. F of 2, since it's a vertical asymptote, I'm not noticing any dot there. My function does not cross over that vertical line of x equals 2, so this is undefined. On to example 7. -2, we're coming into -2 from the left side. -2 from the left side appears that I'm going to -infinity. -2 from the right side is positive infinity. So is there a limit? Oh, why did I say positive infinity? I'm sorry. That'd be negative infinity. It's going down to negative infinity, isn't it? Is there a limit at -2? Yes, indeed, because the left and the right limits agree. So we are going to have negative infinity there. Does f of 2 take on a value? Yes, it does. It looks like its value would be a y value of 0. So, using technology to find limits. Use a graphing utility when necessary to find each limit. So now what we want you to do is get your calculator out and get it ready. Plugging these in, and then we'll read them. So you guys are, I would hope, very comfortable entering a function. I'm going to put, whoops, I can't type on my keyboard, x over square root of x plus 1. If you do not have a graphing calculator at home or close by, just hop on Desmos then and do it on Desmos. So I've got that. I can see that there's probably, and we're going to have probably a vertical asymptote. There's going to be a spot where this is undefined. Would you not agree? And we could do that by setting it equal to 0, set the denominator equal to 0, and we could find that very quickly. I'm going to hit zoom 6, and that is my picture. So use a graphing, determine the limit, and they want the limit of 0. So here's my picture. Let me get rid of my calculator. There's my picture. And now let's just talk about the left and the right side. As I come into the left side of 0, looks like we have a height of 2. As I come in from the right side of 0, I also have a height of 2. So since the left and the right agree, we get to answer that yes, there is a limit. It is 2. All right, example 9. You may not know how to put these in your calculator, but you certainly should be able to read the piecewise function. I know that you've done this work in pre-calc. So let's just make a quick sketch of what's going on. When we're not equal to 2, so for all other x values except when we're at 2, we come out with a y value of 1. So let's just spot where 2 is. When it's not 2, we come out with a value of 1. So I'm going to put a hole there, horizontal line at the height of 1. Then this says when I am at 2, the answer comes out to be 0. That's going to be the dot, isn't it? That gives me an ordered pair of 2, 0. So I get that dot. Now, does the limit exist? How many think yes? How many think no? Well, remember, limits are all about left and right coming together at the same height. And if I follow left of 2, right of 2, they indeed come in at the same height, the height of 1. So this limit does exist. Get used to writing all of this to convey your answer, the limit as x approaches 2 of f of x equals 1. You need all of that. On the AP exam, if you were to not write this, that's not telling me much. That's telling me f of x equals 1. That's a function where y equals 1. That's a horizontal line at the height of 1, isn't it? That's not what they're asking. So you must include the word limit. That's the question being asked. What is the limit? All right. Example 10. You can put this in your graphing calculator. Do so. Hit pause. Go put it in there. I've already done that work. I'm going to pull out my example. And I got a graph that looked like this. From the left, of 0, it looks like I get -1. From the right of 0, I get 1. It's a very common function to be used by the AP. We will see these absolute values like this often. So what's happening as we approach 0? Well, as I approach 0 from the left, I'm down at -1. As I approach 0 from the right, I'm at +1. You know what? Let's take a moment and just write that out, the limit, because this really is my justification. We're approaching 0 from the left of f of x. You know what? I'll put it in the function of absolute value x over x. That had a value of -1, didn't it? And the limit as x approaches 0 from the right of absolute value x over x, that has a height of 1. And for that reason, the left does not equal right. So my conclusion, this means therefore in math, so I can do the 3 dots. The limit as x approaches 0 of absolute value x over x does not exist. Okay? And finally, example 11, find the limit as x approaches 0 of sine of 1 over x. Well, definitely, if I tried to put 0 in there, I have an undefined function. I cannot take 1 and divide it by 0. So we got issues. But that's not exactly what the question's asking. It's asking what's happening from the left, what's happening to the right as I approach the x value of 0. So, there's example 11. With a little bit of scrolling, I can get to it. Let's extend page and bring on the picture for 11. Whoa, what's going on? This is a crazy function. So as it approaches 0, it's doing a lot of oscillating. I can't seem to write on top of this. Let me try again. Yeah, it's coming in, and then it's going crazy, and then it kind of exits and starts balancing out and getting nice and smooth again. Because it does not settle in that middle region where approaching x equals 0, there is not a limit. It would be because it has oscillating behavior, and we will discuss when limits don't exist, and you're going to see oscillating behavior be one of those reasons why limits fail to exist. Sorry, my pen's not picking up everything I'm writing. That says behaviors. So oscillating behavior would be the reason for our DNE. All right. How much more we got here? Oh, I think I have. So why do limits fail to exist? If you have a highlighter, why don't you grab it right now? And let's go through these reasons why limits fail to exist. So using a highlighter, read through this and emphasize the main ideas for each reason. So kind of a little avid strategy here, marking up your text. Please do so. Hit pause and do it. So for number 1, f of x approaches a different number from the right side of C than it approaches from the left side of C. If that's the case, we get this thing called a jump discontinuity. It happens often with piecewise functions. We also saw it on, I'm not going to give it away because that's what we do in the bottom part. Okay, we'll hold on to that thought. Yeah, jump discontinuity. We know, I want to draw you a quick picture of a jump discontinuity. So I have some function finishing here, but then taking off again like that. Definite difference between the left side of its y value and the right side's y value. Number 2, what did you highlight here? F of x either increases or decreases without bound as x approaches C. That means that the function either is infinity or negative infinity, which really describes a vertical asymptote. And that we will see be the definition for a vertical asymptote when we get back into section like 1.14. It's either 14, 15, somewhere in that area. So increasing and decreasing without bound is a reason why a limit can fail to exist. And we saw that in our examples. And then lastly, the oscillating behavior is another reason why limits fail to exist. It just doesn't settle into one value. Okay, so it says in examples 8 through 11, you discovered that 2 of those limits do not exist. You can discuss with a table partner and determine which of the 3 reasons from the box above properly explains why the limits do not exist. Okay, so example 8, if you recall, that one actually did exist, so we didn't have to do that one. Example 10 did not exist, did it? So I'm going to put in example 10. The limit does not exist because of which of the 3 highlighted reasons? I'm going to go for jump discontinuity. We had that jump when x was 0. I may have trouble fitting discontinuity. I did it. There we go. Jump discontinuity. Example 9 did exist. That was that piecewise function. So this one didn't have a jump. It had, as we approached 0, left and right side had the same height. So good to go. But example 11, it did not exist. Which of the 3 highlighted? Go back on your notes. Which reason? Oscillation, oscillating behavior. And I want to try and fit behavior here. It's going to happen. All right. So those are common reasons for limits to not exist. The last thing, I think this is our last question. The figure to the right. Oh, this comes from an AP question. Woo, multiple choice. There are multiple choice questions as well as free response questions in our 4-hour AP exam come May. The figure at the right shows the graph of the function f of x. Which of the following statements are true? And then there are 3 options. So we actually have to analyze each of these 3, don't we, to determine it. A, B, C, D, or E. So see if you can figure this out. Hit pause and then come back to me. The limit as x approaches 2 from the left is equal to f of 2. 2 from the left comes to -1, and f of 2 equals -1. The limit as x approaches 2 from the left of f of x is -1. I have to put a big fat true on that one. Number 2, 6 from the left is equal to the limit from 6 to the right. Okay, so let's get over to 6. Mark your text or your diagram. We're approaching 6. Did these come into the same y value? Indeed they did. This is also true. Looks like it's coming in at a height of -1, if you wanted more information. Okay, the limit as x approaches 6, the limit is equal to the actual coordinate point when I have 6 plugged in. So what is, here's 6 comma -3. That doesn't work, does it? The limit would have been -1, but the point is 6 -3. That is not equal. This is false. So I would have to go and see, I have to see C. C is the answer, 1 and 2. All right. You have some excellent work to do in Delta Math. This will get you so that you're a pro working with limits graphically, okay? There are videos on Delta Math. If you are still confused, please watch some of those. All right, that's all for today. Ta-ta for now.